know that 20% of electricity in the United States comes from nuclear power and accounts for 63% of carbon-free electricity production? Many of these plants will be decommissioned soon due to old age, and if we want to replace them with more zero-emissions power, then advanced nuclear reactors form an essential part of our energy future. In this talk, I will show that not only can you design a nuclear reactor in a university lab, you can collect experimental data that directly supports it. In our research group, we are designing reactors cooled by fluoride salts, which combat the limitations of currently operational reactors. These reactors operate at high temperatures, making them more efficient, and atmospheric pressure, making them safer than current designs. We call these reactors FHRs, or fluoride salt-cooled high-temperature reactors. Heat is produced from nuclear fission reactions in pebble fuel, each one about the size of a golf ball. And the fluoride salt coolant flows through a bed of hot pebble fuel, transporting the heat to a power conversion system, producing electricity. Now, testing new nuclear reactor designs is complicated and expensive. However, there's one astonishing coincidence that makes it possible to design an FHR in a university lab. A particular class of organic oils can actually simulate the heat transfer properties of the salt if certain non-dimensional parameters are matched. The best part about doing this is that we can do experiments at lower temperature scales and smaller geometric scales compared to the actual FHR. So the idea is analogous to geometrically scaled aircraft models that are tested in wind tunnels. I've been studying the heat transfer between the fuel pebbles and the salt in the reactor core by using a scaled model and the oil. So on the right, you can see a test section that's filled with randomly packed spheres, just like the fuel is configured in the actual FHR. And since these sort of conditions have not been studied in the past before, my work is essential to understanding the heat transfer characteristics of this type of reactor. By putting together results from various scaled experiments, we can show that this reactor design is safe and robust and superior to other nuclear reactor designs. So we're all well aware of the climate change crisis that our world is facing. India recently reported the highest temperature that they've ever seen of 51 degrees Celsius. And scaled experiments allow even graduate students like me to contribute to this exciting and growing field. So, thank you.
Awesome. I actually was just recently at a conference that Fortune put on about climate and energy. And the one thing, if you look up fortune.com, they wrote an article. The one overwhelming conclusion was that nuclear needs to be a part of our energy future. And they basically said researchers, investors, everyone should focus on nuclear. So I guess the question is, after you're done with your degree, do you think you'll work for a company that's doing next-gen nuclear?
I would love to, yes. So I'm actually more interested in the research aspect, I guess. So I'm looking to go into academia when I'm done. But I definitely want to stay in the advanced nuclear reactor sector. There are lots of different designs, and we don't know which one is going to make it big. But I certainly hope that the FHR is one of them. So
Awesome. We'll leave it at that.